Welcome, students. So what I wanted to go through today was to work on some of the content from Chapter 3, which is the data collection chapter. So observational study, experimental design are your key concepts there. And what I wanted to also do was go through how you might want to upload your solutions to the AP exam here in 2020. So what I have done is I clipped I opened up the 2018 free response questions, those exams. And we're going to complete the questions that are related to Chapter 3, as well as practice how we're going to upload information or responses to the AP exam. So what I did was in my Google Docs, I created a document and I'm going to title it AP exam type responses. I'm not going to upload a full document. I'm going to type out my responses, copy and paste to the environment that they create for the AP. There is an option, I believe, to upload a full document. That's not what I'm going to do, but you're welcome to do that. You're also welcome to handwrite it and take a picture. But this is how I would choose to do it if I were working through this. Okay, so I created the document before I got in here, and I am going to type, right in here, everything that I want to copy and paste and upload. So here goes. So let's read through this Chapter 3 type question. Most of the content here is from Chapter 3. All right. So you go through and you read this, and some of it, if you're estimating the proportion of students who regularly recycle plastic bottles, that to me looks like a confidence interval. So maybe it is a confidence interval instead. But part of it is Chapter 3 data collection because each student went to the teacher's office one at a time and was asked to respond yes or no to the following question. Okay, so part of this, teachers selected a random sample of students at the school to survey. Okay, so there's some things going on. Most of these questions are going to be a combination of topics. Now, for me, the idea that stands out at this time is it looks like it's a face-to-face interview. Now, one of the ideas, even though that's not part of the question, I'm going to take some notes here. A face-to-face interview, we should immediately be thinking response bias is likely. Now, response bias isn't necessarily, some people would call it one way to have response bias is an intentional lie. Okay. So that is one form of response bias. But in a face-to-face interview, I don't want to necessarily say that people are lying. They're anticipating what the interviewer wants to hear and to kind of, not hurt the feelings of the interviewer or just to gain favor with them in some way, shape, or form, or just, they don't want to be looked badly upon. You're going to modify. I'm not going to call it a lie. I'm going to say you're going to modify your response a little bit. You're going to be careful what you say, and you might, formulate your response depending on who you're talking to. So face-to-face interview has a high response bias. You're going to craft your response or possibly even intentionally lie to look better in the face of the interviewer. All right, so make sure that you understand that that's out there. Okay, let's see. How many students were in the sample selected by the environmental science teacher? How many? Okay, so that's going to be part of our margin of error. That's going to have to do with the confidence interval for proportion is going to use a Z procedure. Okay, so because of how wide the interval is, we will be able to get the sample size in a minute. So that's good. All right, method used. Bias, there we go. That's what I was interested in for Chapter 3. Explain how bias might have been introduced. We're going to talk about that in Part B, it looks like. Okay. Interesting. Okay. So this is a tricky way of coming up with how to get rid of the bias, but there's still going to be some. All right. So let's go through this. So part of it's going to be our inferencing and our process there. Part of it is going to be chapter 3, which is talking about sample design and potential forms of bias. And then we go back to some other procedural ideas. Now, remember, we have a 15-minute time limit here. I'm going to try to hold myself to that. So we'll see how I do. I forgot to start the timer, but we'll see how far I get in a decent amount of time. So part A, okay. Now for the sample size, I'm going to look on my formula sheet and I'll show you where that is. If I was taking this exam, I would have these ready. Okay, it's not a descriptive statistics. It's actually going to be this right here, sampling distributions and inferential statistics. We're going to be using that. Sorry. This part, I'm sorry. Confidence interval. It's the critical value times the standard error of the statistic. So we'll go look on the next page, and it's a proportion. It's a one sample proportion. So our sampling distribution, our sampling error for the sampling distribution, our standard error, I'm sorry, would be right here. Okay, so we got to put that all together. We have to have critical value times the standard error of the statistic together. And then how do we use the response? Let me get back to that. Now, the width of the interval, okay, is going to be a factor as well, 0.584 to 0.816. Okay, so point interval is from 0.584 to 0.816. Okay, so the first thing I'm going to do is grab my calculator. 0.816 minus 0.584, 232. So the width, 0.232. Subtract those. Now our margin of error is actually half of that, so 0.16. All right. Now, so the reason I do half of that is because you have a point estimate in there. You have an exact point estimate. Let's see, what's the average of that? 0.584. 0.7. Okay. All right. Margin of error is 0.16, so it's going to look like this. Our point estimate is going to be our p hat. It's going to be 0.7. And our margin of error is going to be that 0.166. So that's where you're going to get 0.816 on the high side, 0.532 on the low side. No, 0.584 on the low side. Okay. So now we're ready to get the sample size. All right. Sample size is the margin of error equals the critical value. It was a 95%, I believe, so that's 1.96 for the critical value times. Now the standard error of the statistic is the square root of 0.7, because that's what p was, times 3/10. Okay. So that's going back to the formula over here. Standard error of the statistic, we're getting from right there. See, that's it right there, this formula. So that's the one I'm trying to use. 0.7 goes in for p, 0.3 goes in for 1 minus p, or the square root of n, or over n, all of that under the square root sign. So how are we going to solve? So we're going to square both sides to get rid of the square root. First, actually divide by 1.96. So 0.116 0592 basically. All right, so this is 0.0592 equals, now it's square root of 0.7 times 0.3 over 9. All right, now we're going to square both sides. This is not easy. Let's see if we can get the answer squared. Good. 0035. Now this is going to be, okay, and basically what we're going to do is we're going to end up cross multiplying. So it's going to be n equals 0.21 divided by 0.0035. Okay. 0.21 divided by the answer. 59.95. So we always kick it up, even if we didn't, let's say it was 59.1, we'd still kick it up to 60. All right, we always increase the sample size, so n is 60. And then I would make sure that you check to get that correct, to make sure that the margin of error would in fact come out to that. Okay. So you plug in your calculator if you have time. So I'm guessing the sample size for A is 60. Let's see. All right, now go to B. Given the method used by the environmental science teacher to collect the responses, we talked about it, so that was great. That did come up. So B was response bias is high in face-to-face interviews. The science teacher is, okay, so the students are going to probably assume a science teacher, even if they don't know the science teacher, is in favor of recycling. So they are likely to respond in favor, or that they do recycle, right? They're likely to respond yes. So not to disappoint the science teacher. So that's basically what I would say on that. So then I would copy paste that. Response bias. Make sure you say response bias. That's the term from our course that we'd want to highlight. Okay. So modify the response. So not to disappoint the science teacher or gain favor with the science teacher, whatever. So something like that. All right, let's keep going because probably running out of time here. Let's see, potential response bias in the survey. Okay. So now basically a random sample of 300 was selected. Okay, they are trying to put in a random, which is good. In private, flip a fair coin. If heads, you must respond no. Okay. Okay, so basically it's hiding. It looks like it's hiding it from the science teacher. They have to say no if the coin flip came out. Which way? Heads. So if heads, you have to respond no. So now what it is the science teacher isn't sure if it was because of the coin flip they said no, or because they really don't recycle. Okay. And then you can truthfully respond without worrying about being judged there. Okay. Expected number of students from the sample of 300 who would be required to respond no. Well, that one's easy. Okay, so for CI, you're going to say the expected value n times p. Well, you have 300. So p of x equals 300 times 0.5. That's the chance of getting heads. So, pretty simple. Expect 50 to have to say no based on flip 50% chance of heads. I don't know, it seems too simple, but I'm trying to make sure that they can't take off for not fully responding. Okay. Let's see. All right, so it's 213 out of 300. Basically, I would go 213 minus 150 because I've got to assume. Let's see. I got to assume 150 had to say no. 213 did say no. So I'm going to subtract that. I'm assuming half, approximately half. So it's 63. So our point estimate p hat would be 63 over 150, which is what's left. Let's see what that is. 63 divided by 150, the decimal 0.42. All right. Where's that one? Equals 0.42. Anything else on this one? Is that the question? Yeah. Based on the results of the sample, give a point estimate for the proportion of all students in the high school who respond. Okay, point estimate for the proportion of all students at the high school. Okay, so I found the ones that said no. 0.42 would say estimate those that responded no on their own. So 1 minus 0.42 equals 0.58 at for the no's. P hat for yeses equals 0.58. Took 150, assumed 150 had to say no, out 63 remain out of, again, we assume 150 said no. So that leaves how many? 82. So 82 50 prediction. School has yes. All right, so that's it. So I would copy paste that. I would have 15 minutes to do all that and 5 minutes to upload. Now, there's probably more than I could have done, but we're trying to make sure that we at least get a 3 on these. So I feel like what I did was plenty to get, the 3 points at least out of 4, and hopefully maybe a 4. All right, thanks, and we'll try another one in a minute.